Hello guys, you are welcome. In this video, I will guide you through the basics of set theory. We'll cover several segments. First, we'll define what a set is. Then we'll explore the ways of representing sets, followed by special types of sets. Next, we'll look at operations on sets. And finally, we'll dive into analytical proofs of set identities. By the end of this video, you will have a solid understanding of these concepts and how they all connect. So let's get started. What is a set? A set is a well-defined collection of distinct objects called elements or members. Now, emphasis on collection, well-defined and distinct. Collection means a group of objects. Well-defined means we can clearly decide whether something belongs to a set or not. Distinct means there are no repeated elements in a set. What is an element? An element is any object contained in a set. And this is the symbol used to represent element. This symbol means is an element of. But then when you have the same symbol crossed, it means it is not an element of a given set. Now let's move on to methods of representing a set. We'll focus on three methods of representing a set in this video. Number one, statement method or descriptive method. The set is described in words. Example, just as it's given here. Set A is a set of even numbers less than 10. This is a statement method or descriptive method. Second method is the roster method, also known as the tabular method. In this method, elements are listed inside braces. Example. The rules here are number one, we use braces or curly brackets. Number two, each element is separated by a comma. Number three, no repetition. Third method of representing set is the set builder method. In this method, we define a set by stating the mathematical condition its elements must satisfy rather than writing every element. And this is the general form of the set builder method. It's read as set of all x such that, then you state out the condition. For example, we have here A is a set of all x such that x is an element of a natural number and x is less than 10 and x is even. Now, note the sign here, the colon. The colon there means such that. Next up, we have some special sets you should be conversant with. The first one is empty set, also known as null set. This is a set with no elements. It's empty. The second special set is the universal set. This is a set containing all objects under discussion and is represented by the letter U. Third one is subset. Set A is a subset of B if every element in A is also in B. And this is the notation for subset. And it means that if X is a member of A, then X is also a member of B. Take a look at this example. If A is a set of 1, 2, and B is a set of 1, 2, 3, 4, it implies that A is a subset of B because all the elements in A are present in the set B. All the elements in the set A are present in the element or in the set B. So that makes A a subset of B. And fourthly, we'll consider equal sets. Two sets are equal if they have exactly the same elements irrespective of order. Example, this set containing the element 1, 2, 3, and another set containing the elements 3, 2, 1. Irrespective of the order of the elements, they are equal as long as they have the exact same element. Next, we'll consider equivalent sets. Two sets are said to be equivalent if they have the same number of elements. For example, the first set here having ABC and the second set having 1, 2, 3. Although the elements are not the same, but the number of elements in each set is equal. So that makes A and B equivalent sets. Let's move on to operations on sets. Set operations show how sets relate and combine. And we'll look at the following: union of sets, intersection of sets, complement of a set, set difference, cardinality of a set, and power set. Let's begin with union of set. The union of sets A and B is the set of all elements that belong to A or B, or both of them. And let's take an example to show this. It's usual if A is equal to, for example, if A is equal to 1, 2, 3, if A is the set of elements 1, 2, 3, and B, we're given B is equal to the set of elements 3, 4, 5. A union B would be equal to, now the union is everything in A and everything in B without any repetition. So we have 1, 2, 3. We also have 3 in B, but we are not repeating. Remember in set, in defining the set, we said that it has distinct elements, meaning no element is repeated. So we move to 4, 5. So this is the union of the sets given there. So union basically means combine everything in both sets without repetition of any elements. Next, we'll move on to intersection of sets. The intersection of sets A and B is the set of elements common to both sets. Let's call this A and B. Example, using this same example, A intersection B will be equal to, what elements do we have in common in set A and set B? The element number 3. So A intersection B is 3. Next, complement of a set. The complement of a set is the set of elements in the universal set U that are not present in A. Complement. And it's usually represented by, say we are given set A, complement of A will be represented by A prime or A complement. Depends. So the complement of A is of a set depends on the universal set. Let's take this example. We are given that the universal set is equal to 1, 2, 3, 4, 5, 6. And A is 1, 3, 5. So remember, the complement of a set is everything present in the universal set except for what we have in the set we are considering to complement. So in this case, A complement of A is equal to, we have 1 in A, so we compare the set A and the universal set. So what will be in A complement of A will be everything in the universal set that is not in the set A. So in this case, we have 1 in the universal set. We also have 1 in the set A, so we will not include 1. Next up, we have 2 in the universal set, but we don't have 2 in set A, so 2 belongs here. We have 3 in the universal set, we don't have 3 in set A, so we also have 3 in set A, so 3 will not be included. We have 4 in the universal set, we do not have 4 here, so 4 will make it. We have 5 here, we have 5, so to make it. We have 6 in the universal set, we don't have 6 in the set A, so 6 makes it into complement of A. So that's how you find your complement. The complement of a set depends on the universal set. Whenever you are asked to find the complement of a set, you will always be given a universal set to compare with. Next up is set difference. The difference A minus B is the set of elements in A but not in B. That's the difference between A and B is the set of elements in A but not in B. Given this example, A is equal to 1, 2, 3, 4, 5, and B is equal to 3, 4, 5. A is equal to 1, 2, 3, 4, 5, and B is the set 3, 4, 5. We are asked to find the difference between set A and B. So the difference between set A and B is everything present in A that apart from what is in set B. So we have 1 in A, we don't have 1 in B, so 1 makes it. We have 2 in A, we don't have 2 in B, so 2 makes it. We have 3 in A and we have 3 in B, so 3 doesn't make it. We have 4 in A and we have 4 in B. So B, 4 doesn't make it. We have 5 in A and we have 5 in B. So 5 doesn't make it. So the difference between A and B is the set 1, 2. And I'd like you to note that order matters in set difference. While in union, A union B is the same thing as B union A is equal. A intersect B is equal to B intersection A. In the case of set difference, that is not the case. The difference between A and B is not equal to the difference between B and A. Let's show that with the same example. B minus A is equal to, in this case now, we're saying everything in B that is not in A. Do we have anything in B that is not in A? No. Everything we have in B is also present in A. So therefore, our difference between B and A, B minus A, is an empty set. It's a null set. So therefore, the difference between A and B and the difference between B and A are not equal. They are not the same. Next, let's move to cardinality of a set. The cardinality of a set is the number of elements in a set. The cardinality of set A is denoted by this. If A, let's take an example. If A is equal to the set 2, 4, 6, then the cardinality of A is equal to 3. That's the number of elements in the set 1, 2, 3. So that's what cardinality is simply. And then finally, let's consider power sets. The power set of A is the set of all subsets, all possible subsets of the set A. And power set is denoted by P of A. Let's take an example. If A is equal to N1, 2, we are asked to find the power set. The power set of A, P, A is equal to. Now, first of all, note that for every set, the null set is a subset of any set, any and every set. An empty set is a subset of any and every set. So next up, we'll have 1. This set 1 is a subset of A. Next up, we have 2. 2 is a subset of 1 and 2. Next up, we have 1, 2. This is also a subset of this. So that's the subset. It's an array of all the possible subsets. This is what a power set is, rather. It's an array of all the possible subsets of a given set. And something else we should note about the power set is that if the cardinality of A is equal to n, then the cardinality of the power set will be equal to 2 raised to power n. Now, looking at this example, the cardinality of A is equal to 2. So it's expected that the cardinality of the power set P A should be 2 raised to power 2, which is equal to 4. Now, let's look at the power set we formed there. Do we have up to 4 elements? 1, 2, 3, 4. So that's it. That's something you should take note of. Now, let's move to analytical proofs of set identities. Analytical proofs show that two set expressions are equal. That is, they have the same elements. Analytical proofs in set theory are less about solving to get an answer and more about explaining your reasoning logically and step by step. We begin with the expression on the left-hand side, reason carefully using valid statements, and show step by step that it becomes the expression on the right-hand side. Now let's solve some examples. That's with number 1. We're asked to prove that the complement of A union B is equal to complement of A intersection complement of B. So, just like I've said, it's not about solving. What you just want to do is that you want to prove logically and step by step your reasoning, that by reasoning that your left-hand side will equate to the right-hand side. How do we do this? We do this using statements. So, we assume that X is a member of A union, the complement of A union B. If that is the case, it implies, we use this arrow. This arrow signifies implies. It implies that X is not a member of A union B. Because if X is a member of the complement of A union B, it also implies that X is not a member of A union B. And this also implies that X is not a member of A or union. Our union means or A, X is not a member of B. If X is not a member of A, it also implies that X is a member of complement A, or X is a member of complement of B. So if X is a member of both of these, it also implies that X is a member of A intersection complement of A intersection complement of B. So you see that we've arrived at the right hand side, which is this. It's that easy. No solving, just reasoning through. Let's consider another example. Number 2. Prove that the complement of A complement is equal to A. So we assume that X is a member of A complement of A complement, which implies that X is not a member of A of complement of A, which also implies that X is a member of A. Because if X is a member of the complement of A complement, that means X is not a member of A complement. And if X is not a member of A complement, it also implies that X is a member of A. So you see that we arrived at the right hand side. So we've proven rather that A complement of A complement is equal to A. It's that simple. Let's try the third example. Let's try the third example, which is A minus B. We have to prove that A minus B is equal to A intersection complement of B. You want to try this? You could pause here and try this. Okay, let's go. Starting with the left hand side, let's assume that X is a member of A minus B. Remember what we said about A minus B. It means that X is a member of A and it's not a member of B. So this implies that X is a member of A and X is not a member of B, which also implies that X is a member of A and X is a member of complement of B. It's not a member of B, that means it's outside, so it's not a complement of B. And this also implies that X is a member of A intersection B complement of B. So we've arrived at the right hand side. So it's proven. Final example, which is A minus B union B minus A is equal to A union B minus A intersection B. Don't let this scare you. It's still simple. Follow the same process. We start with the left hand side. We assume that X is a member of A minus B union B minus A. If x is a member of this, it implies that x is a member of A minus B, or remember our union means or x is a member of B minus A. Can still go further. Remember that minus means that x is a member of A but not of B. So we say x is a member of A and x is not a member of B, or x is a member of B and x is not a member of A. I don't believe I'm about to say we collect like terms, but that's akin to what we do here. So what are the like terms? Member, not member. So we'll bring the members together, we'll bring the not members together. So we have x is a member of A, or x is a member of B. And x is not a member of B, and x is not a member of A. Now this is the same thing as saying, remember our or is union and our and is intersection. So that is to say x is a member of A union B, and x is not a member of B and A, that is B intersection A. Now if x is a member of a given set and not a member of another set, that's minus. So we have x is a member of A union B minus B intersection A. And we've arrived. Remember that A intersection B is the same thing as B intersection A. A union B is the same thing as B union A. So this is the same thing as saying x is a member of A union B minus A intersection B. So we've arrived back. That is how you do your analytical proofs. And we have come to the end of this video. If this video was helpful to you, please let me know in the comments. If you have any questions or run into any difficulties with explanations or examples, please drop a comment as well. I'll be happy to help. And if you haven't subscribed to this channel yet, please do so and turn on the notification bell so you'll be updated whenever we release new videos. Thank you for watching. I'll see you in the next one.